This set of 6 problems is for us to practice the process of hypothesis testing that you learned last week, so that you will have plenty of examples to go by when you do your practice worksheet 1 and 2. The answers that I put up for the interpretation practice, the 3rd assignment for Chapter 8, those answers were not for that worksheet, so I've got to post those answers this evening after I get home, because I figured out that they weren't right, and then when I went to look for the answers that do go to that worksheet, I can't find them. So I'm going to have to rework the worksheet and put the answers up there. But I will put those up for you by this evening. We're going to start through these problems, and what we're going to do is work through the whole process of hypothesis testing. And we talked last time about what the steps were for hypothesis testing. And apparently I have misplaced the top sheet that tells you what those steps are, but we're going to go through them, so it really doesn't matter. Okay, here we go. So your instructions at the top of the page list out the steps that we're going to need to always do to do a hypothesis test problem. So the first thing that we're always going to do is we're going to write the hypotheses, which actually means we're going to write the claim first. Then we're going to write the opposite of the claim and decide which is HO and which is H1. Then we're going to use our sample information to make a decision about the null hypothesis. And then at the very end, this is the most important part, we're going to interpret the decision by writing a conclusion out in English. And the big thing to remember is when you have your p-value, you want that rounded to 4 decimal places, and the calculator will automatically round it 4 decimal places for you. So the main thing you're going to need to do is to be able to write the interpretation once the decision is made. So here's our first problem. It says a simple random sample of 1,088 adults between the ages of 18 and 44 is conducted. And it's found that 261 of the 1,088 adults smoke. We want to use a 0.05 level of significance to test the claim that less than 1/4, which is 25% or 0.25, of such adults smoke. So the first thing that we do is we look for something that tells us about the claim. And it says to test the claim. So what comes after that is going to be your claim. And your claim is less than 1/4 of such adults smoke. 1/4 or 0.25 or 25%, all of those are proportions. They're not sample means, they're not population means. This is a proportion. Anytime you see a decimal or a percentage, a decimal between 0 and 1, or a percentage, or a fraction as part of your claim, you know that you're testing a claim about a proportion. So the claim is that less than 0.25 is the appropriate proportion, P, for the population. If that claim is not true, then what would be true is that the proportion is either equal to or greater than 0.25. Now, you don't have to have the greater than, you can, but the thing you're looking for is that it would be equal to. And equal to or greater than contains that equals to. So then your next step from there is to decide which of those two is HO and which one of those is H1. And the thing you need to remember is that HO always contains an equality and H1 never contains an equality. So based on knowing that, which of those two is HO and which is H1? What is the claim? The claim is H1. And the reason the claim is H1 is the left-hand sign. It does not include equality. So that tells us then that by default, HO is the other one. And it does have the equal sign, which is what we were looking for. So then we go on and we start looking for the other parts of the information. The beginning of that sentence about the test says use a 0.05 level of significance. A 0.05 significance level. That tells us that alpha is going to be 0.05. And that's going to be important because we're going to use the sample information to get a p-value to compare to alpha to make a decision. So then our next step is going to be to identify the sample information. And the first sentence talks about the sample. It says assume a simple random sample. So the size of the sample is 1,088. And out of the 1,088, 261 of that 1,088 adults smoke. So that's told us two things. It's told us the size of the sample, which is N, and it's told us the value of X, which is the number of those adults that smoke. So that's 261 adults between the ages of 18 and 44. That will tell us P hat. Between the two of those, that will tell us P hat. So that's going to give us the sample proportion, P hat. Okay? So we've gathered all the information now, and the next thing we have to do is we have to decide what kind of a test is it that we're going to do. So you have to choose your test. And the choices of the test are Z-test, T-test, and one prop Z-test. Those are your three choices. And that's because when we go to the calculator and we go to the test menu, that's choice 1, 2, and 5. And this is how you know to choose between them. You choose Z-test or T-test if your claim is about a mean, if it's about mu, okay? You choose one proportion Z-test if your claim is about a percentage, fraction, or proportion. Excuse me?
Less than a quarter.
Right.
But you can make 25%.
Right.
For 55, so you could do that.
So you would have to use a one proportion Z-test. That's right. So this is the correct test. Once you've gathered your information, you have to choose your test. So there's the test that we want. So now that we've gathered the information and we know which test we want, we're going to select that test. And we're going to try to fill in the screen with the information to be able to conduct that test. So we notice that it asks us several things, and we're going to answer all those things. The way that you're going to show your work for these problems is you're actually going to copy down the information that's on that screen. So P sub 0 is the value of P that's in HO. So that means this is P sub 0. Yeah, I'm pulling it out from there so you can see everything. So this is a 1 prop Z test, and P sub 0 is going to be 0.25. And the value of X is going to be 261. And the value of N is 1,088. And what you need to remember here is that N is always greater than X. N has to always be the bigger number, because that's the whole sample and X is part of that sample. And then the third line is actually asking you what does H1 say? Well, the sign in H1 is a less than sign. So you choose the one that has the less than in it. And the reason it's referring to P sub 0 is this is the value of P sub 0, which is, of course, 0.25. So it's saying H1 says the proportion is less than 0.25. That's what that actually says. Now you have two options next. You can either calculate or you can draw. Generally, I will choose to draw the picture rather than to calculate, because the picture actually will answer our question for us. So we're going to choose draw. And if anybody, when I choose draw, if you choose draw and it says dimension mismatch, what you'll need to do is press your Y equals button and look and see if any of your stat plots are on. Plot 1, plot 2, or plot 3. And if any of them have a black box over the top of them, you'll just have to put your cursor on whichever plot is on the Y equals menu and press enter to turn it off. And then go back and run through the test again. So I'm going to draw. And this is why I say draw is the best option, because evidence that favors HO being true is the shaded in part. So when you hit the draw button and your screen comes up and you see a lot of shaded in area under the curve, you're probably going to not reject HO, because that means that black is the p-value. That's where your p-value is, and that means your p-value is large. And p-value needs to be small to be able to reject HO.
Is the shaded area always going to be?
Is it always going to be large, or it always favors HO? The black actually favors HO. The more black you see, the more HO is likely to be true. Okay? So I'm seeing a lot of black here. I'm seeing a lot of shaded in part under the curve. And the reason that I'm seeing that, and that's why I wanted you to draw the picture, because if you learn to understand the picture will help you interpret this. The picture that we see looks kind of like this. Now, what is supposed to be in the center of this picture is HO. Okay? And remember, in order for HO to be found to be supported, your sample needs to be down in this lower tail, because that's a left tail test. But that sample's actually pretty close to the center of the curve. Okay? Things that have a low probability of being true would be down here further away from the center of the curve. Because the low probability would be when you're further away from the center, the shaded part would be in the tails of the curve. So that's why the black is kind of telling us this test is going to come out that you don't reject HO. And the reason that we know that that's true now is because it says that Z is negative 0.7702. And if I rounded that Z-score off to just 2 decimals, which is the way we're used to looking at Z, that Z value is not very far from the center of that curve. It's actually pretty close. And it's also telling me when it says P is 0.2206, it's telling me that's that area that's underneath the curve to the left of Z. Okay? So let's focus on that for a minute. Just for the moment, let's go ahead and calculate what the p-hat value is. And I'll show you the difference in the draw and the calculate menu. The calculate menu repeats to you what H1 said, just to make sure that you got that right. Give you another chance to check it. It gives you the Z value, which we got on the other screen as well, the negative 0.77. It gives you the P value, which is 0.2206, and that's the area that we see here. But the other piece of information, the only other piece of information it gives us that we didn't already know, is it gives us a sample proportion. That Z value corresponds to a sample proportion, which is called a test statistic, because it comes from a sample, it's a statistic, and we're using it to test a hypothesis. So that p-hat value comes from the sample, and what you see there is that the p-hat value actually is less than 0.25, but not much. It's not much less. It would have to be more like maybe 0.20 or 0.21. It would have to be a lot less than just 1 percentage point less for us to be able to reject HO. Okay? So that p-hat value is the borderline here that corresponds to that Z-score. So now that we can think of it that way, then we can form some conclusions about the problem, and we don't need the calculator anymore for that. Because the decision is always made the same way. The decision-making process never changes. The decision-making process says, take your p-value and compare it to alpha. Your p-value is 0.2206. Your alpha value that was given to you in the problem, just look a little further up the page, is 0.05. And all you have to do is decide which way the inequality symbol would point between the two of those. Is 0.2206 larger than 0.05 or is it smaller? It is larger. So your p-value is greater than alpha. Your decision is always if p is less than alpha, you reject HO. But our p-value is not less than alpha. So we do not reject HO. So there's part one of our decision. P-value is not less than alpha, so we do not reject HO. If we do not reject HO, the evidence we have does not support H1. But here's the point. We want to make a decision not about HO and H1 alone. We need to make a decision about the claim. So we need to answer the question in terms of the claim. So this is what we did. We did not reject HO. We did reject, because you can't accept the other one if you didn't reject the first one. Since we didn't reject HO, we have to reject H1 because they can't both be true. But guess what H1 was? It was the claim. So we have no evidence to support the claim. So our conclusion, written in terms of the claim, is the evidence from the sample does not support the claim that less than 1/4 or 0.25 of the population smokes. okay? So that's your whole process. And the only way to get good at that process is to practice it. As you can see, it takes quite a bit of work, and you have to write down quite a few things. But as long as you follow the process, step by step, always follow the process, and make your decisions as you go along about what goes where, then you should come up to the right conclusion. Okay? Does anybody want to ask a question? Yes.
Do we have to draw the picture?
You don't have to have a perfect picture. I will probably on a test, I'll give you a normal curve that you can shade in and label what the calculator shows you. Because I think that really does help you to actually have to shade it in, because when you have to start shading a lot, you're thinking, when I shade a lot, I don't reject HO. And some of these problems are going to make it obvious what you're going to do, even without really looking at the p-value when we draw that picture. Okay? Let's try another one. Okay, this one says a simple random sample of 106 body temperatures has a mean of 98.2 degrees Fahrenheit. Assume from previous studies that the standard deviation of all body temperatures is 0.62 degrees Fahrenheit. Use a 0.05 significance level to test the claim that the mean body temperature of the population is equal to 98.6, as is commonly believed. So let's go through the problem step by step and see what it tells us. The first sentence talks about a simple random sample. So that's everything we know about the sample right there. We know that N is going to be equal to 106. And we know that the problem is about a mean, and that mean is 98.2. So we're going to write that down and hang on to it. The next sentence says, assume from previous studies that the standard deviation, so that's either S or sigma, the standard deviation of all body temperatures. That's a population, which tells us that since it's talking about all of the population, that 0.62 is sigma. So then we keep reading, and it says use a 0.05 level of significance, or a 0.05 significance level, to test the claim that the mean body temperature of the population, which would be mu, is equal to 98.6. So that's our claim. What would be true if the claim is not true? What's the opposite of the claim? Or the complement of the claim? Not equal to. So we wrote the claim, we wrote the opposite of the claim, and now the only thing left for us to do is to determine which one of those is HO and which one is H1. HO always has an equal sign. H1 doesn't have an equal sign. Which one is the claim, HO or H1? It's HO. And that's why right there. Which leaves the other one to be H1. And they cannot both be true. So then our choice is to pick the right test to test the claim. And the claim is about a mean. So that tells us the claim is going to be tested either using a z-test or a t-test. And it's because it's about a population mean mu. So we know that's our two choices. And the difference between those two choices is that you can use a z-test if you know the population standard deviation. So you use a z-test if sigma is given. Is sigma given to us in this problem? Yes. It is, so we're going to use a z-test. Okay? So we know everything we need to know now to be able to actually conduct that z-test. So we're going to go, first I got to turn my lazy calculator on because it shut itself off. And I hit Stat, go to the test menu, choose the z-test. We have stats, we don't have data. It asks us for the value in the claim, and the value in the claim, you can see right here, is 98.6. Then it asks us for the value of sigma, and the problem told us the value of sigma is 0.62. And then it asks us, okay, what is the sample mean? Well, the sample mean is 98.2. And then the next thing they ask us is, how big is the sample? What is your sample size? That's 106. And then what does H1 say? H1 says not equal to 98.6. And there again, we calculate or draw. Now remember, showing your work means you copy down what you put on that screen. So there's your work. That shows me what you did and what you plugged in for everything. So we'll get the picture. Anybody see any shading on that curve? What does it say P is? P is 0. So what this basically has been telling us with that picture, we assumed that the center of the curve was 98.6. And then we used the sample information to find out that the sample mean, x bar, is equal to 98.2. Well, 98.2 certainly is less than 98.6. That doesn't sound like a lot less. That's only 4/10 of a degree. But that 4/10 of a degree goes down 1, 2, 3, 4, 5, 6 over 6 standard deviations. If I continue this axis all the way down here, this is where my sample fell. Because the Z value that corresponds to that 98.2 is negative 6.64. And the area to the left of a Z-score like negative 6.64 is going to be pretty close to 0. If we rounded it to 4 decimal places, it would be 0. Okay? Now, before I leave this, just to make sure everybody understands, I'm going to do the calculate part of it. Now, that p-value that it's called 0, the actual p-value is 3.1039 times 10, because that's what E means, to the negative 11 power. So this p-value is actually,
How'd you get to that square again?
you just use calculate instead of draw. So there's your p-value. But remember, we said we round p-values off to 4 decimal places. So if you round that p-value off to 4 decimal places, what is p? It's 0. And when I give you your test back in a little while, there's a few of you going to read on a problem where you wrote down an answer for a probability, and I marked it wrong, and I wrote, go back and read the whole answer. Because if the only thing that you read on that p-value was 3.10, and you wrote down 3.10 as an answer, you should know better than that. What are the only possible values of p? What do they have to stay between? 0 and 1. So can you have a p-value, a probability that's 3.10? No. So remember that when I give you your test back. Not everybody did it, but a few people did. Okay, so knowing now all of that information, what do we conclude when we compare the p-value, which is 0, to the value of alpha, which is 0.05? Does it really matter what alpha is? It could be 0.000001. We would still reject, because 0 is always going to be less than anything alpha could ever be. So when you get a p-value of 0, that always means p is going to be less than alpha. So if you see a p-value of 0, you're going to reject HO. So we've decided that HO is not true based on the evidence. What does that mean about the claim? The claim's not true. They've told you all your life the mean body temperature is 98.6. It is not. And that really is true. I've had a lot of experience with medical situations and things, not because I wanted to, because I was thrown into them. And I have found more and more people, I almost never see anybody that I know any of this kind of information about. Almost no one has a body temperature that's 98.6. Most people have a body temperature that's lower than that. Some people, several degrees lower than that. So we reject HO, which means we reject the claim, because the claim is HO. And if we reject the claim, then our conclusion is going to be written the sample evidence does not support a claim that the mean body temperature is 98.6. And that's really all you need to say. Either the evidence supports the claim or it doesn't support the claim. That's really all the final sentence has to say. The evidence supports the claim, the evidence does not support the claim. And you determine whether it does or doesn't based upon whether or not you rejected HO and whether or not HO was the claim or the claim was H1. Okay? Any questions? Anybody still need to be making any notes? Okay, let's do one more and then take a short break. I'll give you back your tests, and then we'll finish up the other three. So our third problem says, when planning for the construction of a parkway, engineers have to consider the weights of cars to be sure that the road surface is strong enough. A simple random sample of 32 cars yields a mean of 3,605 5 3/10 pounds with a standard deviation of 501.7 pounds. That sentence is our evidence because it's all about the sample. And then it says use a 0.01 significance level that tells us alpha is 0.01 to test the claim that the mean weight of cars is less than 3,700 pounds. So our claim is mu is less than 3,700. Which means that if mu's not less than 3,700, It's either equal to or it might be greater than 3,700. You can use the greater than sign if you want to, but it has to be equal to or greater than. Is the claim HO or is it H1? Claim is H1 because it has an inequality sign in it. Okay? That means that this is HO. So then we need to gather up the sample information that we're going to use to test it with. So we gather our evidence. There's a sample of 32. That has a mean of 3605.3. That would be X bar. And a standard deviation, and since it comes from the sample, that would be S, of 501.7. So there's our evidence, and there's our alpha's 0.01 as the judge. Now we got to be the jury. The claim is about a mean. Therefore, we either choose z-test or t-test. Which is it? It's t, because we don't know sigma. We have S. Since we have S, we have to use the t-test. Then once we've made that decision, all we have to do is go to the t-test and answer the questions. So the information that we have comes from statistics, not data. The value of the mean in the claim is 3,700. The value of the sample mean is 3605.3. The value of the sample standard deviation is 501.7. And our sample size is 32. And then the last thing is, what does H1 say? And H1 says less than. And we'll draw. Always double check your screen before you actually draw to make sure you didn't transpose some numbers or put a decimal in the wrong place or forget to put, actually you probably didn't forget to put decimal in, but it just didn't pick it up when you punched the key. So always double check that screen. And then once you do that, you draw your picture. And I start seeing a lot of shading. And when I see all that shading, what do I start thinking? I'm probably not going to reject HO. So I'll sketch the picture up here and we'll actually come to a conclusion. And these pictures don't have to be perfect, it just has to have the shading kind of in the right area and about the right size. So remember, what was being claimed was that the mean was 3,700. And when our calculator finished shading everything in, it said that this t-value was negative 1.067, and that this p-value is 0.1469. So given that information, we're going to compare p to alpha. And is p less than alpha? Is it less than 0.01? No. P is not less than alpha. P is greater than alpha. So do not reject HO. Is HO the claim? No. And since HO has not been rejected, the claim has been. Okay? Since HO is not rejected, and HO is not the claim, then the claim has been rejected. So that means our evidence does not support the claim. So we haven't been able to support the claim. The claim is probably not true. Now I want to back up for a minute. This is not actually part of the problem, but it gets to the idea of interpreting. So we have, the evidence doesn't support that claim. When they planned the construction of the parkway, they need to be sure the road surface is strong enough. Apparently, the strength that they need is for the cars to weigh 3,700 pounds or less. Or actually to weigh less than 3,700 pounds. If they need, in order for the road surface to be strong enough, if that's what they need to have, does their sample tell them that they met their criteria? Do the cars that are going to be traveling on the road surface weigh less than 3,700 pounds? The answer is no. So what should they do? They better plan on shoring up the strength of that road surface, because the cars that are traveling on it are going to be weighing more than what their current road surface is enough for. Do you ever wonder why after a nice long winter that your highway, when you're driving on the summertime, it's nice, but then after the winter, you're zipping down the same road, what do you hit? Potholes, because they didn't take into account all the weather conditions and the road conditions they needed to when they surfaced that road. And that costs a lot of money. So these ideas that you're learning have a very practical significance.
Can you scroll back down to the,
Sure, I'll just push it up so you can see it. Does that help? Okay. So we're gonna take a short break, about 10 minutes maybe. And we're gonna do the other three problems. But before you take off, I'm just gonna hang out right here, kind of in the middle of the room. Sierra. Bretland. Austin. Tim. Michaela. Addie. Ashley. Harley. Jacob. Rachel while I'm down here. David Leonard. Amelia. Jordan. Dave. Taylor. Taylor Shell, she's not here. Taylor Corbett's not here either. Chelsea Perry. And I want to tell you something that I observed just as I was going through the test. And I'll actually provide you with the difference in the exam scores on this. The people that did and turned in the practice test, even without the practice test points added to their test score, did a lot better than the people that didn't do it and or didn't turn it in. And I don't think it was because the practice test added points, although that certainly did help people that had done the practice test because it meant they had studied harder and therefore they did better. But those of you that didn't do it, think about what 5 points would have done to the grade you got. It was a free 5 points for doing what you were supposed to do. Maybe you ought to think about doing it next time. Okay? If you have questions about the test, you can come up and ask me at the end of class. And I'll be glad to explain anything you did wrong. Or anything that maybe I did wrong grading, because that's a possibility too. The problem that some of you may want to look at, that I made the comment about, was problem number 24. Y'all can take a few minutes break. I've got to go down and pick up a couple of tests that I haven't graded yet from the CSD office. So y'all can take a few minutes to look at your test. So example 4, as soon as it starts talking about randomly selected adults, we know that we're talking about the sample information. So that first sentence is going to be our evidence. There's our sample information. And what that's told us is that N is 30,617. and that out of that 30,617, 5,787 of them consumed herbs within the last 12 months. And what we're going to do is use a 0.01 significance level to test the claim that fewer than 20% of adults consumed herbs within the last 12 months. Now, when we see 20%, is that a mean? That's a proportion, so that determines what our test is. So our proportion is that P is less than 20%, but when we write it as a claim, we need to write it as a decimal. So we're going to write it as 0.20. And then we know that because the claim is that it's less than, then if the claim's not true, it would be equal to or greater than. And we'll just use the equal to. And since the less than is the inequality, then that's going to be H1, and the opposite's going to be HO. Does anybody have any questions so far?
The equal sign would be greater than or equal to.
It could be, yes. It would be just fine if that said greater than or equal to, as long as you've got the equals to. Okay? So then this decision about what we're going to use to perform the test, if it's a proportion, we really only have one option at this point, and that is a 1 proportion z-test. And when we do that test, the first thing it's going to ask us is, do you have data or do you have statistics? Well, we have statistics. And then it's going to ask us questions about the sample evidence. So it's going to ask us first, what is the claimed percentage or proportion? And of course that's 20%. And then it's going to ask us what's the value of X, that's the smaller of the two numbers from the sample, 5787. And then what is the size of the sample, and that's 30,617. And then what does H1 say? H1 says less than. So that's how we're going to fill in. And then we're going to draw the curve. So when we draw that curve, this is what we see. And I don't see any shading. Okay, there's no shading here. And the reason there's no shading is because our p hat value is all the way down there. And the reason we know the p-hat's about all the way down there is this is -1, -2, -3, -4, and this would be pretty close to -5. It's z equals -4.8063. And that's why it tells us the p-value is equal to 0, because the p-value is so small that if we rounded it off to 4 decimal places, it would actually be 0. So we have a 0 p-value. Now, if you want to know why it's that far down, you can actually calculate. So it's 5787 divided by 30,617. That sample proportion is 18.9%. And we know that from those two numbers there. So yes, it is less than. It's a whole lot less than, even though it doesn't look like that 1.1% would be that much. These actual increments, remember, are standard errors. They're very small. So it didn't take a lot to make it actually that much less than. So we're going to compare the p-value of 0 to the alpha value of 0.01. Not that we need much comparison, because it's easy and quick to conclude from there that p is less than alpha. 0 kind of beats everybody. So we reject HO. And if we reject HO, HO is not the claim. The claim is H1. So that means the evidence our summary statement says sample evidence supports that the percentage of people who consumed herbs was less than 20%. And then we have this little statement at the bottom that says an entrepreneur only wants to open up an organic shop selling fresh herbs if at least 25% of the 25% of the population uses them. Based on the evidence we use to test this claim, should that entrepreneur open up that shop? What do you think? No. No, at least 25% of the population doesn't use them. We've shown that less than 20% use them. So no. The evidence doesn't show that 25% or more of the population would buy the herbs. They shouldn't open the shop. there again, a very realistic situation where evidence might help you make a good decision. Okay? Now we've got one that uses data. Insurance Institute for Highway Safety conducted tests with crashes of new cars traveling at 6 miles an hour. The total cost of the damage to the cars was found, and the results are listed below for a simple random sample. So here's our sample evidence, and we're going to put it in list 1. And we're going to use alpha equals 0.05. To test the claim that when tested under the same conditions, the mean cost in damage to the cars is $5,000. So there's your claim. Mu is equal to $5,000. And what's true if the claim is not true is that mu doesn't equal $5,000. And since the equal sign is in the claim, that's HO, and the alternate is H1. So let's put the data in the calculator and test this claim. So we're going to go to Stat, choose Edit so we can enter the data into one of these lists. We don't care about list 2, we'll just clean out and use list 1. So we have 7448, 4911, 9051, 6374, and 4277, which is the 5 cars. You just enter those 5 car damage totals into list 1. And then because we have no idea what the population standard deviation is, it was not even mentioned, so all we have is the sample to go on, then we're going to do a t-test. And our t-test this time is going to be with data. So with the data we have, we're going to test the claim that the mean is 5,000. And our data is in list 1. And we're testing H1 saying that the mean is not equal to 5,000. So of course we're going to want to make a note of that. So you make sure you write that down because that's your work. And then draw the picture. And I'm seeing an awful lot of dark shading, so I'm thinking probably HO's true. and it says the t-value that goes along with our sample data has a positive value of t, that's 1.6389. But because it's a two-tailed test, because this says not equal to, the total p-value is the p-value for the upper tail plus that same p-value in the lower tail added together, which turns out to be 0.1766. So anytime you have a does not equal to an H1, then you're going to see a two-tail test and you'll see shading in both tails. So that p-value, just like we always do, is going to be compared to alpha, which was 0.05, and of course 0.1766 is not less than 0.05. It is greater than. P is not less than alpha. Do not reject HO. So this is what we think is true, and this is what we think is not true. HO is the claim. Since I chose the claim, the evidence supports the claim. So the evidence supports the claim that the mean damage cost in this kind of collision is $5,000. Anybody have any questions? Okay, we've got one last problem. And then remember, next time we're going to start chapter 9, so as soon as I get them posted, which will be later on this evening, go ahead and print out your notes and stuff for chapter 9, because we're only going to spend the next class period on chapter 9. This one talks about the heights of supermodels as our evidence. So I'm going to try to be quick about writing all this down. A sample of 9 supermodels found to have a mean of 70 inches and a standard deviation of 1.5 inches, and that comes from the sample, so we're going to use a t-test. And we're going to use alpha's 0.01. Because that's what it tells us to do. And test the claim that supermodels have heights with a mean that's greater than the mean height of 63.6 inches for women in the general population. So basically we're trying to use a sample of supermodels to prove that they're taller than most women. So that's the claim that we're testing. And that means that if that claim is not true, then the mean would be equal to 63.6, or it might be even less than 63.6. As long as the equal than is there, that's all you need to have. That means that the claim is H1, and its opposite is HO. And because we only have sample information, as I said, we're going to use a t-test. And we're going to go from statistics. And the claimed mean is 63.6. And the sample mean is 70. And the sample standard deviation is 1.5. And the sample size is 9. And H1 says the mean is greater than. So we'll fill all of that in. And this is what we see. So there's the claimed mean. And it says that our sample mean, X bar is 70, is 12.8 standard deviations above the mean. So it would be just like way off my paper. It will be so far up the curve that I can't even see it. And that's why the p-value is 0. And as soon as you know the p-value is 0, you don't have to compare it to alpha, because alpha is never going to be 0. 0 is always going to be less than alpha. You're going to reject HO. And since HO is not the claim, we have supported the claim. And what that means is that supermodels are taller than the normal average woman. Okay? If you have questions about your exam, stop by. I'll stick around for a little while in case you need to know something that you did. I will have your quiz questions, your quiz grades posted to you in your grade report for today.
Would that be okay to say too? Because we're rejected them.
There was evidence supported the mean height for women in the general population. No.
Because that was...
These women are the supermodels. And they're trying to say these supermodels are taller than what the average woman is. So the claim is not about the average woman in the population. The claim is actually about the heights of the supermodels. See? Well, read through your problem again and make sure. And if you don't, then I'll be glad to go over it with you again.
I don't understand any of this, so it's okay.
Remember that your conclusion always goes back to your claim. Who was your claim about?
Will this class go all the way up to the final, or will there be a break in between?
There is no